All right, good evening, everyone. These are your notes for Monday's class on equations. We're doing one-step equations. This is chapter blue 1.11 and 1.12 in your book. The notes go on page 103 of your Ian. Don't forget to date your notes. Your essential question: compare and contrast in your own words and complete sentences the terms expression and equation. Remember, we've been using expressions for a while, and actually you've been doing equations for quite some time without actually knowing you were doing it. An equation is a number sentence that has a variable and an equal sign. So make sure you've got that in your notes. Let's get this little down. An equation is a number sentence with an equal sign and a variable. A number sentence with an equal sign and a variable. All right, so an equal sign and a variable. Now, to solve an equation, which simply looks like this, got my marker there, x plus 4 equals 11. This is an equation. You can have any letter you want, but you got to use a letter, okay? No more smiley faces, no more hearts, no more stars, no more gray boxes like you had in first grade. You got to use a variable. X is the most popular, followed by N. You never really want to use the letter T because it kind of looks like a plus sign. All right, the goal of solving equations is to isolate, which means to get by itself, the variable or the letter, while keeping your equation balanced at all times. Meaning you don't want to add or subtract or multiply or divide more to one side than you do to the other, because then it's no longer equal. You can see that in our little balance scale in our picture. This came from your book. Excuse me. You have your equation the way it was, and you can see they added a yellow brick to both sides, keeping it balanced. In numbers, you can see that all they did, if you have 2 plus 3 equals 5, if you add 4 to both sides, you haven't changed the equation at all. You added exactly the same thing to both sides. And you can see the way it looks in algebra as well, because soon you'll be doing that as well. All right, so let's go ahead and solve a few. These can have adding, subtracting, multiplying, or dividing. It doesn't matter, and you're going to practice all of them today. Step 1 is to determine the operation that is in the equation. That's your first step. So our first equation is going to be 69 plus p equals 117. Now our variable is p. There's our variable. And the operation is addition. So that's step 1. Its operation is addition. Step 2 says to perform the opposite operation to both sides of the equation. And we do it to both sides to keep it balanced. That way we're not doing anything just to one side, because if we only do it to one side, it'll be lopsided. So, change colors here. All right, so since the operation in the problem is addition, the opposite is subtraction. Now I cannot add or subtract a letter, so I have to deal with my numbers. Also, the whole goal is to get rid of this 69 so that all I have left is p equals something. Remember, the goal was to isolate the variable. So all right, so we are going to subtract 69 because subtraction is the opposite. And remember, I have to not only do it to one side, but I've got to do it to the other as well. Okay? So 69 minus 69, well, guess what happens there? They cancel out. And there's nothing left. It makes 0, leaving my p all by itself, which is step 3. Okay, I'm going to have that p all by itself. Then I'm going to ask myself, 117 minus 69. This is at the point where you could just punch it in the calculator or do the math. So we get 17, make that one a 0. 17 minus 9 is 8. Take and borrow again. I get 10 minus 6 is 4. So I have P equals 48. Then you must write your solution as P equals 48. You cannot just write 48 because that wouldn't be the answer. We already had an equals 117. We needed to know what the P equals. Now, the cool thing about equations is they have a built-in answer key. You can go back and check your work and go, okay, well, what is 69 plus 48? Does it equal 117? Well, 9 and 8 is 17. Carry the 1, 6 and 4 is 10, plus the 1 I carried is 11. So yes, it does equal 117, so I know my answer is correct. All right, let's do one more example with multiplying or dividing. Remember, if you don't understand any of this or it gets confusing, all you've got to do is ask during class, and I'll be happy to show it to you live. But remember, you've got to ask. If you don't speak up, I can't read your mind. Alrighty. A division problem. Let's look at this. How about x over 7 equals 20? Now remember, this is not a fraction. Do not get scared. It is not a fraction. No need to worry. No fretting allowed. This is not a fraction. Remember, that line stands for division. Okay? I'll write this just a little bit neater. Okay? So if it's a division in the problem, the opposite is multiplication. Opposite is multiplication. Okay? So that means I'm going to multiply this side by 7. Let me change colors here. Multiply this side by 7. And I'm also going to multiply this side by 7. Now, this is a divided by 7 times 7. They cancel out always, every time. Do not write 7 times 7 is 49, because then you haven't gotten your x by yourself. They cancel out, okay? I multiplied the x by 7, and I divided the x by 7. That means they cancel out. So I bring my x down. I get 20 times 7. I know that 20 times 5 is 100, so plus 2 more, that's going to be 140. I also know 7 times 2 is 14. Then I double check. Is 140 divided by 7 equal 20? Yes, it does, so I know it's right. And you always use a calculator to double check. All right. Happy doing your assignment. Watch out, look on your syllabus, make sure you check what your assignment is. And I will see you in class.